Before we get into the new stuff for today, I'd like to take a look at that AP Prep worksheet we were looking at with those really strange looking limits. Yeah, I'll get the lights on. We took care of some of this stuff last time, but there was one type of problem we haven't yet dealt with.
I was saluting my fault.
Let's see. So we're looking at that sheet that looks like this. Hopefully we have this sheet. Please take that out. I think we talked about 1 and 2 and 4 and 5, and we didn't do 7 or 8, but they're the same. What?
I have that sheet. What is
I
that?
bet it's at home. Well, I have exactly enough for, well, like whatever. I'll make another copy for whatever class that is, G block. Okay. I'd like to, so we had our formal definition of the derivative. We saw how to do things like 1 and 2 last time, all really involving recognizing that we're using the formal definition of the derivative. That's how they're going to test these things on the AP exam. You need to be able to recognize what the function is, and then find the derivative using shortcuts. And you need to recognize that the formula they're giving you means find the derivative. There was another version of the derivative, though, that we looked at, the alternate definition of the derivative, that said f prime of c equals the limit as x approaches c of f of x minus f of c over x minus c. That was our alternate definition of the derivative. If you take a look at a problem like number 3 on your worksheet, where we have the limit as x approaches 4 of the square root of x minus 2 over x minus 4, this is exactly in that form of the alternate definition of the derivative. It's saying our function is what? F of x is what here? If this is in this form over here. Square root of x. And it's saying, let's find the derivative where? My alternate definition is f prime of c equals, well, this whole thing over here. Where do I want to find the derivative? 4. Limit as x approaches c, limit as x approaches 4, x minus c, x minus 4. I want to find the derivative at 4. That's what problem 3 is telling you to do. So go do that. Find the derivative, not using any formal stuff, using all of our shortcut rules, and when you're done, plug in 4. By the way, this thing over here, this 2, is just the square root of 4. That's my plugging 4 into my original function. That's why it's 2 over there. Maybe something like that. Try number 6. Are we doing number 6? Because I gave you a whole extra sheet. Now I need to copy another one for the other class. So I think we should do that. What a good plan. What's f of x in number 6? What? Cosine x. And I want to find what? F prime of pi is what 6 is asking you to do. Okay, well, f prime of x is the negative sine of x. So f prime of pi is the negative sine of pi, which, yes, is 0. That just wasn't my question. You're going to see a couple more of these in the review packet for the test. But basically, this is how I'm going to test you on the formal definitions. If you're not going to have to do these lengthy calculations, you're going to have to recognize a problem in one of these forms, realize what it's asking you to do, then find the derivative with the shortcuts, and either you're done, or then you go plug in a number to the derivative. We are done between today and Thursday. Our review day is Friday, and the test is next Tuesday. You'll get the review packets next time. Okay. last big topic we're going to look at is called the chain rule, and this is section 2.4. And this is a big deal. Number 6 should be 0. What did I say? I meant Wednesday. Sure, because there's no school on Monday. Yes, yes. Yes. Okay, so I think we should get moving so we can finish this because I don't see you like ever anymore for things. Chain rule. The whole point of this last derivative rule is this lets us deal with derivatives of compositions of functions, one function inside another. This lets us deal with derivatives of compositions of functions. For example, you know how to find the derivative of y equals the sine of x, but now we're going to do the derivative of y equals the sine of 2x. You know how to do the derivative of x to the fourth, but now what if we have x squared plus 3x, that whole thing to the fourth? And you know how to do the derivative of the square root of x, but now we're going to do the derivative of the square root of x minus 2. Actually, one of these you could already do. It would be a real pain, and we're going to see a better way to do it, but which one of these could you actually already do? Yeah, foil again, we've got to see a shortcut for that. Here is our chain rule. It says if I want to do the derivative of f of g of x, of one function inside another function, I'm going to take the derivative of the outside function, f prime, and I'm going to leave the inside function inside there, f prime of g of x. And then I'm going to multiply by the derivative of the inside function. So in this case, I'm going to multiply by the derivative of g. The derivative of f of g of x is f prime of g of x times g prime of x. And I'm not expecting this formula itself to make a whole lot of sense. Let me show you a couple other ways of thinking about this thing. And we'll talk later about why it's called the chain rule. There is a reason. Can't explain that yet. So let's say I want to do the derivative of y equals the sine of, I don't know, of something. Something more complicated than just x. If I want to do this, my derivative is going to be, my formula says take the derivative of the outside function, leaving everything inside there, and multiply by the derivative of the inside. Well, my outside function here is that sine. What's the derivative of sine? I'm going to get the cosine of that thing. And the chain rule says I should then multiply by the derivative of that inside piece. So whatever the derivative of that thing inside is. I'm going to take the derivative of the outside thing, leave everything inside. Then I'll multiply by the derivative of the thing inside. What if I had y equals something to the fifth power? How do you do a derivative of a fifth power? 5 out front, and then what's the new power? 4. So your derivative is going to be 5 times whatever that thing is to the fourth. But the chain rule says I then need to multiply by the derivative of that thing that's inside. Maybe? We're doing the derivative of the outside function. In this case, it was something getting raised to the fifth. How do you do the derivative of a fifth power? 5 times that thing to the fourth. But by this new chain rule, it says when we're done, we need to multiply by the derivative of that thing inside. If I had y equals the square root of x, which is, of course, the same as saying y equals, well, what?
The
thing to the 1/2. You know what? See if you can go make a formula for this thing. We're taking the derivative of the outside thing. I'm taking care of that 1/2. Leave that thing inside there. And then I'll just say at the end times the derivative of that inside piece. One half times that thing, the negative 1/2, times the derivative of the inside part. I think we need to see how to use this for real. First example we're going to look at, first real example, h of x equals x squared plus 1 to the third. I want to find the derivative of this. I think this is very similar to the problem, h of x equals something to the third. Which says if I want to do the derivative, I would do 3 times that thing to the second times the derivative of the thing inside. For this problem, I want to take care of that outside function, that cube. That 3 is going out front. I'm going to get 3 times x squared plus 1 to the second. That is my f prime of g of x, part of the formula. But the chain rule says I then need to multiply by the derivative of the thing inside. What's the derivative of the thing inside? That's my derivative. I probably shouldn't leave it like that. I should probably write it as h prime of x equals 6x times x squared plus 1 squared. But that's how the chain rule works. I'm taking the derivative of the outside function, leaving everything inside there. Then I multiply that answer by the derivative of the thing that was inside. I'm kind of like chaining one thing to something else to maybe more things. That's kind of the point. Do you think you can do one on your own? See what you can do. F of x equals 3x minus 2x squared. That whole thing raised to the 5th. See what you can do. Hoping you're starting with something like that. 5 times 3x minus 2x squared to the 4th. Raising your hand, who can tell me what else I need? Ryan.
Times, in parentheses, 3 minus 4.
Good. I don't see any need to try to rewrite this in any other form. I think that's good enough. We're going to want things either fully expanded or fully factored. We're basically fully factored. Are you kind of with me? Yes?
You wrote it as negative 4x plus square root, would you accept?
Absolutely, that's fine. Yep. Next. Making these a little bit tougher. Let's say f of x equals the cube root of x squared minus 1 squared. How can you make this look prettier right away? Maybe not prettier, but better for us to do a derivative.
You can do x squared minus 1 to the...
How about you go find the derivative of that thing? Now it's written in a good way that we can go use chain rule. Go find the derivative. Remember our rule when you're done of not leaving any negative exponents? It's going to matter in this problem. So I dealt with my 2/3 power, 2/3 out front, new power is negative 1/3, 2/3 times x squared minus 1 to the negative 1/3. But the chain rule says I then have to multiply by the derivative of that inside part, so times 2x. This one I do need to do some cleaning up on. Maybe 4x over 3 times x squared minus 1 to the 1/3 for a derivative here. Anything with that? Okay. What about, let's move on to t's, because we can change the variable and that shouldn't do anything to it. G of t equals negative 7 over 2t minus 3 squared. I want to see if you can rewrite this so it's in a good form for us to use chain rule. And then go use the chain rule. Negative 7 over 2t minus 3, that thing squared. Hopefully that's negative 7 times 2t minus 3 to the negative 2. Do I need the product rule here? Because that negative 7 times that thing? No, just our constant multiplier rule. You're going to say negative 7 times whatever your derivative by the chain rule of 2t minus 3 to the negative 2 ends up being. Getting 28 over 2t minus 3, that thing cubed. Let's do some trig. And I really don't think I have to explain much here. I just want to see what you guys can do. I want you to do the derivative of y equals the sine of 4x. And when you're done, see if you can also do the derivative of y equals the tangent, with that new formula that hopefully we knew on that quiz, of 2x squared minus 1. There's something inside both, so we need the chain rule. The derivative of the outside function, leave everything inside. Multiply by the derivative of what's inside. So the cosine of 4x times 4, or 4 cosine 4x for the first one. It's the derivative of a tangent. Secant squared of the thing inside. So secant squared of 2x squared minus 1. Do I need anything else? Yeah, like what? 4x, the derivative of the thing inside. I'm going to rewrite this, and I'm going to say 4x secant squared of 2x squared minus 1. Next. Y equals the cosine squared of x. You saw this notation last year in pre-calc. What am I squaring here? What was that? The cosine x. This is just a shortcut way of writing y equals the cosine of x, that thing getting squared. I actually think it's going to be easier if I write it in this other notation to help us kind of think about what's going on, because When I write it like this, what is the outside function? The cosine or the square? The square. That's what I need to deal with first when I go to do my chain rule. Y prime equals 2. Cosine x to what power? First, okay, so I'm not going to say anything there. Now what? Times negative sine x times the derivative of that thing inside. Your derivative of cosine squared x is going to be negative 2 sine x cosine x. By the way, would it have been okay? I wrote it as cosine x in parentheses squared. Could I really just write this as like y equals cosine x squared like that? What is this kind of implying is getting squared? That means something very different. That's not what this problem is asking you to do. It's saying let's square that entire cosine x thing. One more trig thing. Let's take a look together at y equals the sine of 3x, that thing raised to the 7th. Take a moment, write that in a better looking form for us to use the chain rule on. This is the shortcut way you would have written it in pre-calc. But let's write it better showing what's going on here. So like that. Okay, watch this carefully. What is the outermost function? Something to the 7th. Okay, so our derivative is 7 times, leave everything, sine 3x to the 6th. But now, I've got to do the derivative of sine 3x. What's weird about that? It's like a function inside a function. There's kind of like 3 layers to this particular problem. On the outside, I have my 7th. Inside that, I have a sine. Inside that, I have a 3 times the thing. This is a 3-part chain rule problem. I dealt with the 7th. Inside there, I have a sine. What's the derivative of sine of something? So I'm going to say times the cosine of leave everything inside there. But by the chain rule again, I need to multiply by the derivative of what's inside that. What's the derivative of 3x? Do you see where I'm getting my 3 layers from here? On the outside, I had that 7th power. Deal with that first. I dealt with that. Inside that, I have a sine of something more complicated than just x. So do the derivative of that. Derivative of sine is cosine. Leave everything inside there. Times the derivative of the thing inside. That's a 3. I'm going to clean this up a little bit. I'm going to say y equals 21 sine 6 3x. I'll write it like that. You can write it with parentheses. That would be fine. What I'm not okay with is you saying 21 sine 3x to the 6th cosine 3x, because that implies the 3x is getting raised to the 6th. If you're going to write it like that, you need another layer of parentheses. But it should look something like that. Anything so far? Okay. I have 3 more problems that I want to look at. I'm not sure if we'll get through all 3, but let's see what we can do. And they kind of go in order from easier to harder to hardest. Actually, not really easier. Hard to harder to hardest. 3 tougher problems. I would like to look at f of x equals 2x plus 5 to the 4th times 3x minus 1 to the 6th. This is our hard one, as opposed to harder or hardest. Do you see some chain rule that's going to happen in this problem? You've got something inside other functions. But there's more to it than that. I see another rule. Do you see a product here? Actually, I kind of see that as my outermost function, so I need to go and I need to use the product rule on this thing. Let me write this down. I need to go use product rule. Then, within product rule, when I go to do the derivative of the first or the derivative of the second, that's where my chain rule is going to come in. So let's go do this part together. F prime of x equals first 2x plus 5 to the 4th times the derivative of the second. Volunteer to tell me how we do the derivative of 3x minus 1 to the 6th? Maybe? Claire, tell me something.
6 times 3x minus 1 times 2
Good, because we need to use the chain rule. On the second part, when we're doing the derivative of that, take care of the sixth power, make the new power 5, but then multiply by the derivative of the inside, so 2x plus 5 to the fourth, times 6 times 3x minus 1 to the fifth, times 3, the derivative of that inside part. Am I done with the calculus part here? There's more. I just did first times derivative of the second. We need second times derivative of the first. Second is 3x minus 1 to the sixth. You go take a moment and do your derivative of the first, which is going to require chain rule. Stay awake. Stay awake. I know it's warm. We're almost there. Maddie, do you have that second piece?
4 times 2x plus 5 equals times 2.
Perfect. Here's the good news. We're done with the calculus part of this problem. But I need to be able to clean this thing up. Take a moment and just make this piece look a little nicer, make that piece look a little nicer, and then we have some more work to do together. Really, I'm just saying multiply the 6 and the 3 and the 4 and the 2. I want my answer to be either fully distributed, yeah, I'm not doing that, or fully factored. And right now, I'm not because of that plus in the middle. But I feel like hopefully you can look at both pieces and see some stuff. Like what?
Should the 18 not be in front of the 3x minus 1 to the fifth? Or?
It's a big multiplication problem, so it doesn't matter where it goes, but usually we'll just put any coefficients out front. Does anyone see anything we could do with these? I'm thinking like a word that starts with an F that you've been doing for a... Is that a hand, Eli? There's a lot of factoring we're going to have to do, and specifically, like, greatest common factor, factoring. Let's start with the 18 and the 8. What can we take out? I think that's the best we can do there. I'm going to take out a 2. Right now I'm looking for the GCF. Now, you see both pieces have a 3x minus 1. I want to factor out the most 3x minus 1s that I can, which is really like the 3x minus 1 to the lowest power I have in any piece, which means 3x minus 1 to what gets taken out? To the fifth. Because each of the terms has 5 of those 3x minus 1 pieces. This one just happens to have an extra one. How many 2x plus 5s can I take out? 3. Because I've got 4 there and 3 there. I'm going to take out the, well, most that I have in any one piece, that's 3. So I'm going to take out a 2x plus 5 to the third. I got to deal with what's left. Let me just kind of try to think in reverse here. 2 times what gives me 18? 9. 3x minus 1 to the fifth times what gives me 3x minus 1 to the fifth? 1. We're already good there. Okay. 2x plus 5 to the third times what gives me 2x plus 5 to the fourth? Or to the first or whatever. I'm just going to say 2x plus 5. Sure. You see if you can deal with the other part. And I think the best way to do this is think about 2 times what would give me the 8. 3x minus 1 to the fifth times what would give me the next piece. Think about multiplication in reverse. What's the number? 4. What is left? 3x minus 1. We're almost there. I can't leave this like some partially factored, partial like something that... Go and just distribute things inside here to get like things that you can combine like terms on and get just one thing inside a set of parentheses. see if you can get what I have. I do want things like this fully factored, so I don't want you to just leave it as that second line over there. Even though we're done with the calculus, I want to see if you can factor this as much as you can, and really the key with this factoring is greatest common factor stuff. Questions on this? Okay, so that was the hard one. Now we need to look at the harder one. Is anyone still copying things? Yes. You will need some sharp pencils for this next one. Oh, there is a sharpener right in front of you. Whatever, go. Yeah, of course. X squared. Whoops, hold on. F of x equals x squared times the square root of 1 minus x squared. Take a moment, write that in a better form. Do you again see a product rule thing that's going to happen here? And will both parts of the product rule again require you to use the chain rule? Chain rule on this, chain rule on that? I don't think so. I think just the second one will require chain rule. See if you can go do your product rule with chain rule. Don't do any simplifying yet. We'll do that together. But see if you can get the calculus line taken care of. First times derivative of the second. Derivative of the seconds are going to require that new chain rule. Plus second times the derivative of the first. And actually, when you're done, do clean up the two terms. I want to do the GCF part with you, but at least there's some stuff you can do in that first term. I think I have that. Oh, wait, hold on. Are you talking about over here?
Yeah.
Do you see where that's coming from? Which is fine, as long as you have both pieces there. So the 1/2 and the -2, they cancel. Maybe negative x to the third times 1 minus x squared to the negative 1/2 plus 2x times 1 minus x squared to the 1/2. I think. Is anyone with me? Questions? GCF stuff. X cubed, 2x, what's coming out? X cubed, 2x, x. Now, I should be able to do something with that 1 minus x squared thing that each term has. My rule from the previous problem was I factor out that term to the highest power or the lowest power. Over here, I had stuff like this. I had 2x plus 5 to the fourth, 2x plus 5 to the third. I took out 2x. Right, 2x plus 5 to the fourth, 2x plus 5 to the third. I took out 2x plus 5 to the third. I took out the lowest power. So, with that in mind, what is my lowest power? To the negative 1/2. Okay, let's do that. 1 minus x squared to the negative 1/2. Well, the good news is I won't have any of those in my first term. What will I have in that first term? Negative x squared. X times what gives you negative x cubed? Negative x squared. Then I'm going to have 2, and I'm going to have some sort of 1 minus x squared thing. I'm going to say 1 minus x squared to some power that I just haven't figured out yet. If we think about kind of multiplying in reverse. This times this needs to give me 1 minus x squared to the 1/2. When you multiply things, what do you do to the powers? Add them. Negative 1/2 plus what would give you positive 1/2? Negative 1/2 plus what would give you positive 1/2? 1. Your power is actually just going to be 1. Why? This thing to the negative 1/2 times this thing to the first negative 1/2 plus 1 gives you positive 1/2, what I wanted there. See if you can finish it. Clean up the rest. We've taken care of the ugly parts. When you're done, see if you can write it like that. I'm almost certain there's one of these in the homework. By the way, homework is book stuff. It looks like a kind of weird order. I'm telling you, do 7 to 21 odd, 43 to 51 odd, then 27, 29. There's a reason I went in that order. I want you to take care of kind of the straightforward chain rule stuff first and save some of these weird things for later on, after you're kind of more comfortable with just basic chain rule. And by the way, because of the holiday, if you're dealing with that on Wednesday, take care of the homework tonight so it's done and out of the way. Not supposed to give homework assigned Tuesday, due Thursday, but Monday, due Thursday is fine. So take care of it tonight if you're dealing with stuff on Wednesday. Okay, one more, the hardest one. We're not going to finish this, but I do want to at least get the thing started. We did the hard one, the harder one. Last one we're doing, f of x equals x over the cube root of x squared plus 4. I want to do the derivative of this thing. And why is it different? What's different? Quotient. Now, what's easier, product rule or quotient rule? Product rule is easier, but this is the quotient rule. This is why I said this is going to be harder. I really don't want to do this. I don't want to do this. I don't want to do quotient rule here.
You could do product rule by making it to the negative 1/3.
That's the first part of this. This is going to be ugly, doable, but ugly if we keep it as a quotient problem. Why don't I not? Why don't I turn this into a product rule problem and make this thing f of x equals x times x squared plus 4 to what? To the 1/3, negative 3, negative 1/3? Not negative 3. Negative 1/3. It's a cube root on the bottom. That's a negative 1/3. That's the first important step. I feel like there will be a quotient in the homework. Don't do it. Make it a product rule thing and go from there. There's a little more to this one that I want to talk about, but I feel like we either have 20 seconds left or a minute and 20 seconds left, and that's not enough to do anything. So we're going to pick this one up next time. I have very little new stuff to do. We got to do some graphical and numerical stuff. Maybe, hopefully, we can spend some time doing like some group work on Thursday just to kind of do some random things with chain rule. Okay, so I'm not going to push the delete button.